All right, so with this division, really what we're doing, right, is we're checking to see if 2b minus 7 is a factor of this polynomial. When we start our synthetic division, we're going to take this factor, 2b minus 7, and we're going to set it equal to 0, and we're going to come up with a potential solution. Okay, remember that's always how we get solutions, is we take a polynomial, we factor it, and we take each factor and set it equal to 0. So we get b equals 7 halves. Now, as of now, we don't know that 7 halves is a solution or not. We just know that it could be a potential solution. We'll figure this out based on what remainder we get after going through the synthetic division here. But we needed to start here because with synthetic division, we put that potential solution in the chair. Okay, so the language here, what's the solution or 0, as well as what is the factor. 2b minus 7 we think is a factor, and thus we're checking if 7 halves is a solution. Then we're going to bring in all the coefficients. So negative 20, 50, 58, 44, and negative 7. And we're going to have to work with some fractions here. Now again, if you struggle with the fractions, use a calculator. Okay, when you're using the calculator, make sure you're putting parentheses around the fraction. That makes a huge difference. And a lot of you have already kind of ran into issues with that when working with those fractions. All right, so regardless of what number's in the chair, we always bring down that first number. That doesn't change. Now what we're going to do is multiply negative 20 by this fraction. Now, how I explained it before and how we deal with fractions is we multiply the numerators together. So I do negative 20 times 7, and then I would divide that by 2 times 1 or divide it by 2. Well, I can't do that in my head. So another way that carrying out this multiplication and the simplification works is we can actually do the division part to begin with. So I can go negative 20 divided by 2 is negative 10. Right? Would everyone agree with that? Negative 20 divided by 2 is negative 10. Then I take that result of that division, negative 10, and multiply it by my numerator. So negative 10 times 7 is negative 70. No calculator needed to multiply and simplify those fractions. If you didn't catch that, I'll do it again here in just a second. So 50 minus 70 is negative 20 again. And so once again, to do this multiplication, I'm actually going to divide by the denominator. So negative 20 divided by 2 is negative 10 times 7 gives us negative 70 again. So then we'll add straight down. Would that be negative 12? And then once again, I'm going to do negative 12 divided by 2 is negative 6 times 7 is negative 42. Bring down or add these numbers together to get positive 2. This one's a little bit easier because 2 divided by 2 is 1. 1 times 7 is 7. And we get a remainder of 0. Okay, so because we got a remainder of 0, we have essentially factored. And remember, what we did is we took this original polynomial and we're saying that it is equal to 2b minus 7 times this quotient. But we need to interpret what this quotient is. Now, there's one really important piece of this, what these coefficients are representing. This is not actually a negative 20. All these coefficients aren't actually what we're going to use. And what we need to do as this last step to actually get our correct factoring is we need to take all of these numbers and divide it by the same denominator that is in the chair. So whatever is the denominator of the chair, we always need to divide our coefficients by that number at the very end, except for the remainder. The remainder does not get divided by that. Here it won't matter, but these coefficients need to be divided by 2. And thus we're going to get new coefficients of negative 10, negative 10, negative 6, and 1. And these coefficients give me the expression of negative 10b cubed minus 10b squared minus 6b plus 1. Okay, so that's the kind of sneaky part with that. And one way to kind of know that this works out is, right, if I were to multiply these two factors together, I should get the original polynomial. And so this highest degree term, that negative 20b to the fourth, I get by doing 2b times that negative 10b cubed, right? That gives me negative 20b to the power of 4. Had this been negative 20, though, it's not our original equation, okay, or at least not up to that point. All right, so all those numbers have to get divided by whatever our denominator is in the chair. Yeah, Liam, go ahead. So this 2 came from, so there's two ways of how we can pick up on this 2. What is the GCF of all these numbers we got after adding there? 2, so that's one way. The other way is whatever that denominator is in the chair is what we'll divide by at the very end. Yeah. Exactly. Yep. If there isn't a fraction, right, like take our warm-up problem, for example, right, negative 4 is kind of like negative 4 divided by 1. So it's almost as if we divided all these by 1 and it doesn't change it. So it's just whatever that denominator is, we'll divide those coefficients by that number at the very end. Okay. Or just look for a GCF with those numbers at the very end. Okay. That's another thing that you could also do to catch that. All right. Well, why don't you all try, does that say 5m minus 5? Is that what I had up there? Dang it. Why does that? Why don't I like that? What's going to go in the chair? 1. All right, so let's do this. Let's switch this up. And for everyone watching the video, this is now the homework page. And we're going to work through, let's do problem number 6. Okay, we'll do that in class right now. And then that way we're knocking out a homework problem while also reviewing how to do this fraction work. So everyone work through number 6 right now. After you're done, we'll go through that. I don't know why this thing won't focus. There we go. Okay, so everyone do number 6. Come on. We'll just take a look at this one real fast. And then I'll let you all just continue to work on this homework assignment. So in the chair, you end up getting negative 10/6. If you want to reduce that down to negative 5/3, that is okay. It doesn't change the values. Okay, so some of you might recognize that 6 and 10 are both divisible by 2, and you might put negative 5/3 in the chair. That's okay. That's the same fraction. Okay, so it still works out the same. Regardless, I bring down the 6. Then again, the quick way to do this without a calculator, I take that 6, divide it first. 6 divided by 6 is 1. Then multiply it by the numerator, and that's how I got negative 10. 10 minus 10 is 0. This 0 needs to be there because we don't have any quadratic terms, so you need a placeholder for the x squared. And when we get these zeros, it makes a couple of those numbers easy. Because 0 times anything is 0. 0 plus 0 is 0. 0 times anything is still 0. So then we get negative 24. That negative 24 divided by 6 is negative 4. Negative 4 times negative 10 is positive 40. And negative 34 plus 40 is 6. Now again, the last part of this, which is sneaky and really doesn't, synthetic division is just crazy how it works out this way to begin with. But the only things that are going to get divided are the non-remainder coefficients. So that 6 and the negative 24, they all have a GCF of 6. And again, you can pick up on that GCF by whatever was in our denominator to begin with. Okay, so all those get divided by 6, making our quotient and the result of the division x cubed minus 4 plus the remainder of 6 divided by what we were originally dividing by, which is 6x plus 10. Question did ask to state whether or not this is a factor. Because we got a remainder of 0, we would say that this is not a factor. And thus, it really doesn't do much for us. Okay, but we can at least write a quotient for what that works out to be. All right.